Welcome back, guys. Today we are going over these 5 Z15 boards that I just got in from a customer. So we're just going to do basic diagnosis intake right now and log them into the spreadsheet so I keep track of them and share it with the customer. So first things first, good, the barcode's still on here. The problem with these Z15s is they lose their barcodes here at the bottom, and then it's hard to keep track of them. So we're going to go ahead and scan it in. All right, so I got my multimeter on the right and my power supply on the left on the screen there. So this one, obviously, it's already been, somebody already diagnosed it or worked on it, as you can tell here. So I'm not sure what's going on with that. So in initial things here, we want to test. Make sure there's no shorts on the board. You just shove the ground right there in the heatsink. $1.8K, $2K. All right, we're good. No shorts there. Next, we're going to put some 12 volt on here. Here we go. All right. Drawing 0.2 amps. We're going to switch over to volts. And then we're going to try to see if we can. First things first, do we have 3.3 volts? Yes. All right. Do we have 5 volts? Yes. Now I'm going to turn my amperage down so that if one of these MOSFETs are shorted when I power it, it doesn't just blow something up. So right here, I'm going to jump for this. So we're drawing about 2 amps there. I'm going to turn it up just a little bit more. We have a short on the board somewhere, so I don't want to keep injecting voltage there. You can hear clicking over here. So there's obviously a short on this chip here. Let me try something. When we turn the amperage down, turn on the MOSFETs, and see what kind of voltage is. All right, so we're not shoving voltage in there. All right, good. So we know this one's bad here. So we're going to go ahead and log that in. Obviously, somebody's already diagnosed it, so I'm kind of getting somebody's seconds, which I hate, but chip 3 short. Okay, so that's that. On to the next one. All right, so this one doesn't have any writing on it. Go ahead and scan it in. See if you can go through that captain tape there on there. Come on. You can do it. There we go. Okay. Again, you just go switch over to resistance, test for shorts on 12 volt, and we have a short on 12 volt. So what we're going to do, get our thermal camera out here, turn that on. Now I have to the 12 volt power supply turned all the way down on the amp, so it won't do anything yet until I turn up the amperage. All right, wait for my thermal camera to boot up. Now I don't be able to hook it up and show you. It's going to be a bit of work, so I'll just tell you once I find the problem. So let me go ahead and give it some amps. Nothing's really getting hot on this side of the board. Go ahead and okay. The only thing getting warm is around chip number 3. So there's a problem with chip number 3 on this one as well. Let's go ahead and test and see how much voltage is coming through here. If I turn the amperage up, yeah, see, there's a short on one of these MOSFETs actually. It's just going directly through. As you saw, as I turned the amperage up, the voltage went up, and then in turn that just went directly into the core. So that core is probably bad. But there's a problem here on the power. So if I would have just put 12 volt on it, which obviously had 12 volt originally, it would have just went straight to the core. So it's not looking good. I don't see anywhere where any of the MOSFETs particularly getting hot, but they are going directly into the core. All right, so this one's done. We're gonna go ahead and take some notes on this one. All right, that's done with this one. Go ahead and mark there. So remember when I pick it up what it is. All right, on to the next one. All right, no barcode on this one, so we are gonna have to use some other number on here. We're just gonna go ahead and use this one, H1702 1C EOH. Okay, just gonna do that. All right, again, ground. Let's test for shorts, put on resistance. All right, this one's good. Ohms is going straight up. Okay. That's pretty normal voltage. All right. Let's go ahead and test on 3.3 here. Let's switch to. All right, let's test for 3.3. Good. Test for 5. Pretty good, a little low. All right. So let's go ahead and make sure our amperage isn't too high here. When we turn these MOSFETs on, you can see it pulling some power. Okay, 0.78, good. Nothing. All right, nothing on 1 and 2. We have power issues on 1 and 2 here. So let's go ahead and document that. We're done with the power. All right, so that's done with that. Well, someone's already diagnosed this one before, but I don't know if they did it properly because there's no power here. So we have no power. We have no power. We have power here. So I'm guessing it probably read these 2 chips and stopped because there's no power. I don't know. Maybe they. We'll find out. We will find out. All right, on to the next one. This one has a barcode. Okay. Let's go ahead and do the same thing. Test for shorts on the board through the 12 volt. Resistance again. Okay, we're going straight up. That's good. Put power up to it. Okay, we're drawing a good amount of power where it's supposed to be. Okay, let's see if we have 3.3. Yep. 5. Yes. Okay. It's a healthy 5 too. So. All right, so let's go ahead and test the okay. 0.78. 0.78. 0.78. All right, so we got all power. Let's go ahead and test 1.7 on the back here. 1.7 is good. Let's test the 0.8. I mean 0.7. You got 0.7 there. So everything checks out as far as power. Let's try one more time. 0.78. 0.78. All right, so that's all good. So we're going to have to throw this in the test machine and test and see what's going on with this one. So I'm going to just note that here. All right. On to the next one. And for the last one. Nope. Switch to resistance. Okay, no shorts, just pants. All right. Okay. All good there. Let's go ahead and hook up the power. Okay. Let's test for 3.3. Yep. 5. Yep, good healthy 5. Let's go ahead and test. Ooh. Okay, we got a healthy amperage draw there. 0.78, 0.78, 0.78. All right, that's all good. Let's test for 0.7 on the back. Oh, gotta have ground on there. There we go. Okay, we got 0.7. Got 1.7. All right, so we have all power here, and we need to test. Okay. I'm guessing, I don't know what that means. It's like 313 BC BL. I'm not sure. So let's go ahead and document this. All right, so that one's done. Now for giggles, let's do a little more exploring on this board without power on these two rails. So what we need is our adapter. Go ahead and plug them into here. Then we need our USB here. All right, let me get this set up for you. Okay, we need power. There. All right, let me get this set up. All right, here is the power client to read the controllers on the board here. So you can see here, this one has an error because it says it's 255 degrees, which is wrong. It's an issue with one of the MOSFETs probably, or the feedback circuit. Now this one here, let's go ahead and find out what its problem is. All right, and then we want to hit the telemetry. All right, so everything looks, I just cleared the fault. Everything looks normal. So let's see what happens when I power it. You can see right there, there's the fault. Overcurrent protection. So there's a short somewhere, or it thinks there's a short. So there's an overcurrent protection on that one. Yep. So that's what that issue is. And then the other controller, the first one, is an issue with temperature. So that's how I diagnose the no power issue. So another thing to note is on the way these are in line, the number 1 controller is here, controls number 3 ASIC, number 2 controls number 2, and number 3 controls number 1 ASIC. So they're backwards to the number of ASICs, just so you know and don't get confused if you ever do figure out that program. So all right, so that's it for today. We're just diagnosing these boards and documenting it. So we can go ahead and start on the repair process. Thanks for watching. See you next time.